This lesson is for AP Calculus 3.1D, and you'll be using derivatives and chain rule using tables and graphs. Hopefully you have this handout right in front of you, and you can see that there's some really beneficial information about f, f prime, g, and g prime evaluated at both 2 and at -6. Okay, so the first thing I want to point out is that we are trying to find h prime of 2 for each of these examples down below. So for the first one, I'm going to kind of zoom in a little bit. Here we go. For the first one, they define that h of x is equal to f times g. All right, but I need the derivative, right? In order to find h prime of 2, I need to know what h prime of x is. So since these two functions are being multiplied, I'm going to be using the product rule. All right, now if you remember, the product rule is the derivative of the first times the second plus the first times the derivative of the second. Okay, now I want h prime of 2, okay, which means I need to put a 2 into each of those places where x used to be. And luckily for us, up in the chart, I have numbers for each of those, right? If I look closely, I have f prime of 2, I've got g of 2, I've got f of 2, and I've got g prime of 2. Let me put those numbers in. I believe they are -3, -6, 8, and -4. And if I finally simplify that, I'll get 18 plus, oh, actually, I made a mistake. That's a -8. That multiplies to be 32. So h prime of 2 in this case is 50. All right, now when we go over here to part B, I have a brand new definition of what h is. Okay, it's no longer being multiplied. Now I've got 5 times the first function plus a separate function. So I still have to take the derivative. So h prime of x is going to equal, now a constant times a function when you take the derivative is just the constant times the derivative of the function plus the derivative of the second function. Okay, so now again we're trying to find h prime of 2, so let me change those x's into 2's. And then this is where your handy dandy chart comes in. And we can actually plug in numbers for f prime of 2, which is -3, and g prime of 2, which is -4. So continuing, I have h prime of 2 equal to -15 minus 4, so h prime of 2 is -19. Okay, so for part C, I now have function composition, which means I have to use the chain rule on part C. So let's figure out how to derive h prime of C. All right, so it's going to be the derivative of the original function times the derivative of the stuff inside. Okay, so then I need to change those things into 2's. It's f prime of g of 2 times g prime of 2. All right, so let's keep going. So now I have f prime of, let's see, g of 2 is -6. And g prime of 2 is -4. So then I need to continue to evaluate. Again, that chart is coming in really handy, wouldn't you agree? F prime of -6 is 8 times -4. So again, using notation all the way down, I get h prime of 2 is -32. Okay, let me scoot this up and see if I can talk you through the ones with the graphs. Okay, so for this picture, or these pictures, I should say, they tell us up at the top that h of x is actually equal to this function composition, all right? And then it wants us to determine this value, which means we need to compute what the heck h prime of x is. Now, we're in luck, actually. We just did this up above, right? We did h prime of x when we had to use the chain rule. So it is f prime of g of x times g prime of x. Okay, so there's the chain rule. So now I need to actually plug in the value up here that they gave me and in there and see what I can figure out. Here we go. So h prime of negative 2 is equal to f prime of g of negative 2 times g prime of negative 2. Okay, now the only one of these that I can actually fill in right now based on the graphs that are given, I can plug in this part. And the reason I can do that is if I come over here to my g graph and I go to negative 2 as an x value, I should probably use a narrower point here, negative 2 right here, I can see that that equals, actually hold on, I'm having a hard time seeing that. Let me zoom in a little. I think they mean for it to equal negative 5. I'm looking at Mrs. Rawson's notes right now and she has it as negative 5. It's not the best drawing in the world, but we're going to go with it, okay? We're going to go with the fact that g of negative 2 equals 5. Okay, so let me zoom this back out. So that one number that I know right here is negative 5, right there. Okay, now what I don't know, at least based on these pictures, I don't have a graph of f prime of x or g prime of x. But what I do remember is that f prime of x and g prime of x is about slope. Okay, so let's take a look at those locations and see if we can figure out what the slope is at that location. I'm going to use a highlighter. So this is saying I want the slope of the f function at negative 5. Well, here's negative 5, and that slope is 1. Okay, so I'm going to put a 1 in there. Let me start writing this out. Give me a sec. H prime of negative 2 is going to equal 1. Now let's take a look at the other graph. I'm going to switch colors on you here. So this is saying what is the slope of the g graph at negative 2? Well, the slope here, if I'm looking really, really close, I think is negative 2. So here I'm going to write negative 2. All right, and when you finally multiply those all together, I'm going to have to move because I'm out of room. I'm hoping that I get h prime of negative 2 is equal to negative 2.